Hi, this is Sister Edith. Welcome to week 2 of our Statistics for Professional Practice course. I'm happy to be sharing the topic of variability, also known as dispersion, with you this week. It's one of the most important concepts. It goes along with our central tendency concept, which tells us what a typical score would be like, and variability says how often does that typical score occur. In this first dispersion video, we're going to look at the concept of range and also add in a few things that were left out by our textbook, most particularly the interquartile range and the box plot, which is a way of graphing dispersion or variability. In the second video, we'll look at how to compute a standard deviation and also a variance, which are measures that we'll use for the rest of the course. And in subsequent videos, we'll look at how to use the standard deviation in computing a score's location and also some elements of using the normal curve to talk about probability. So let's dig into this important topic. I'm looking forward to sharing it with you. Dispersion, or some of its synonyms, variability, spread, or dissimilarity, measures how much scores differ from each other and from the central tendency that we learned to measure in Module 5. In the three pictures on the left, you can see 3 different winning sports teams. The top picture shows a fraternity softball team, and you can see moderate variability of the height of the players. They all tend to be fairly tall, but some are significantly taller than the others. In the middle, you see the North Carolina State women's volleyball team, and even though there is some variability, a few of them are a little shorter than others. In general, they're pretty consistently a tall group of women. And finally, at the bottom are the MIAC winning golf team one year, and you can tell that there's quite a bit of variability from the tallest to the shortest. So we want to be able not only to have the concept, but to find ways to measure it and express it numerically. Our Statistics Alive textbook introduces the concept of the range, and in this video we add to it a concept that is seen really often in healthcare, education, psychology, and other literature, that of the interquartile range. So overall, the range is the distance from the smallest to the largest number in a distribution, and it can be affected if there are outliers or extreme values. The interquartile range basically lops off the bottom quarter and the top quarter of the scores and keeps the middle 50% and computes the range there. And this is a way of looking at what the central group, regardless of outliers, would look like. To see how these measures work, we're going to use an example of 2 students, Julian and Delia, who come to a tutor center asking for help. They're in the same class, and they have the same average or mean quiz score of 15 out of 25, and they'd both like to be doing better. In the examples, we're going to compute our 2 scores, a range and an interquartile range, and we're also going to learn a new type of graph, a box plot. Here are Julian's quiz scores on his 20 quizzes. When we look at them, we find that his top score was 18 and his lowest score was 13. So to compute the range, we need to use the real limits. So the upper real limit of his top score would be 18.5, and the lower real limit of his lowest score would be 12.5. When we subtract the lower one from the upper one, we get the range, or 6 points. The interquartile range tells us to lop off or ignore the bottom 1/4 and the top 1/4. Out of 20 scores, a fourth or a quarter would be 5 scores. So if we look for his lowest scores, we know that 13 was his lowest, and then from there we get 14, which happened several times. And when we've cut off those 5 scores, we can see that we've got yet another 14 will be where we find that quartile range. We can do the same thing for his upper scores. 18 was his highest score, and then we see he had a 17 and some 16s. And now we've found the top 5 scores that we've eliminated and the lowest 5 scores that we've eliminated. And so the remaining score of 16 will be the top end of his interquartile range to go with the lowest score of 14. And when we do that using the upper limit of 16.5 and the lower limit of 14, which is 13.5, and subtract them, we can see that interquartile range is 3. Overall, we're seeing that Julian's scores are fairly similar across all 20 quizzes. Delia's scores go from a high of 22 to a low of 8, and when I compute the range using the real limits, I find that the range of her scores is 15. Remember, the range of Julian's scores was only 6. Even when I remove the most extreme scores, I've already crossed out her top 5 scores and her lowest 5 scores, we find that her interquartile range is a high of 18.5 minus a low of 12.5, or 6. So Delia's middle 50% of her scores has the same range as Julian's entire range. We can tell that Delia's scores differ quite a bit from quiz to quiz. So probably whatever is happening with Delia is different than what's happening with Julian. She sometimes has a superb performance and sometimes a very poor one. In the tutor center, we would probably give different advice to each of these students. The box and whiskers plot is one that's not shown in the textbook, but it is one of the most common in health, education, and other types of research. It was designed by John Tukey in order to be able to display central tendency and variability, and to do so in such a way that it's possible to compare groups. So the box that we have here is drawn with the 75th percentile, in other words, the upper limit of the top 75% at the top, and the bottom of the box is the 25th percentile. So in the middle are the middle 50% of the cases, and the median is shown as a line wherever it would fall in the box. The whiskers go out to the farthest score that actually occurs in the data, so long as it's no more than 1.5 times that interquartile range from the box. So the whiskers are saying, in essence, what's the range of reasonable data? And then if there are really extreme values or outliers, they're shown as asterisks or pluses or something like that. So when we look at the box, we can see central tendency, and we can see the range of the middle or most typical values, and then the full range of the data. It's a very efficient way of looking at a data set. Here we're looking at the box plots for Delia and Julian's quiz scores, and you can instantly see why this plot is so useful. We can tell at one glance that Delia had much greater variability in her score. Her highest score was higher and her lowest score lower, and even the middle 50% of her scores had a lot more variability. Julian, on the other hand, even though he had the same mean and close to the same median, is showing much less variability. We can also tell, although it's subtle, that Delia's scores are slightly skewed. When you look at the line for the median, it's slightly closer to the bottom of the box than the top, and that's an indication of skew in the positive direction. In a second example, a researcher thought that it seemed to rain much more on the weekends than on weekdays in his area, so he plotted the average daily rainfall over a year for weekdays and weekends. And as you can see, it looks as though he had an accurate perception that on average it rained more on the weekend. We can tell that by comparing the central tendency. We can also see that there's somewhat less variability. The height of the box for the weekend is less than the height of the box for the weekdays. We also can see that there's a significant skew in that the median and the lowest, the 25th percentile, are very close together, and there's a much longer distance from the median to the 75th percentile. So that's indicating something of a skew in that data as well. In summary, our general measures for dispersion that only take into account a few data points include the range, or the difference from the highest to the lowest score, which will be affected by extreme values and can be computed with interval or ratio data. We also had the interquartile range, which is the difference between the 75th and 25th percentile. It's not so affected by extreme values. It also requires interval or ratio data to be computed. And finally, we looked at a box plot, also known as a box and whiskers plot, which is very useful for showing central tendency, skew, and dispersion all in a single graph, and is used frequently in medical, education, psychometric, and other literature in order to compare groups. The next video in our sequence on dispersion takes up the variance and the standard deviation, two of the best-known measures of variability, but ones that take a little bit more effort to compute.